Hello, everyone. We will wait for a couple of minutes for everyone to join, and then we'll start. Okay, I would suggest we start. Hello and welcome everyone to this NERO Cybersecurity Training webinar. Today we have again 3 modules for you under the overarching umbrella Advanced Threat Detection and Privacy Protection for SMEs. My name is Ole and I will be your host for today. This webinar is part of a 3 webinar series. We already had our first webinar last week on the basic 3 modules of cybersecurity. Now we're taking it a step further with more advanced topics, and we're going to round off this webinar series in January with 3 more modules. Before we start, a little bit about the NERO project. The NERO project is funded by the European Union, and it started in 2023 and is part of the Digital Europe program. The consortium from NERO has 16 partners from 10 different countries, as you can see here on the map. The main objective of the NERO project is to build an advanced cybersecurity awareness ecosystem focused on SMEs, and to demonstrate the benefits of NERO through 3 use cases in the healthcare, finance, and transportation sectors, and also to help SMEs through training, which we're going to focus on today. The main outcomes of the NERO project are the aforementioned cybersecurity awareness ecosystem, but also the NERO marketplace, which hosts or where SMEs can find a number of tools and training courses from EU vendors. Next, the speakers of today. The lectures today will be given by Wissam from Montimaj, Eleni from Tostilio, and Dimitris from Mainz. Before we start, a few tips for today. The Q&A will happen entirely through the Q&A box. So if you have a question, please post it there, and we will answer your question throughout the panel or in written form and directly in the chat. The recordings, as I saw the question already earlier, will be shared later on through our website, as well as the slides. Those will also be shared later on with you. This training webinar is part of our research project work. That's why we would like to ask you to fill out our questionnaires to assess the trainings. Yes, so here we have, first of all, the pre-training questionnaire. So we would be really happy if you could scan the QR code or follow the link that we will post in the chat to fill out this questionnaire before we start the training if you haven't already done so. Thank you so much in advance. I would say we take a few minutes and then we'll continue. All right. I think we will continue. I will leave the QR code here on the side in case you haven't had a chance to scan it yet. One thing I want to mention also, of course, we would really be happy if you could help us with the questionnaire. Also, if you would like to receive a certificate for attending this webinar, we are asking you to fill out both pre and post questionnaire. The latter will come later after the session. Yes, my last point for now is the agenda for today. So as I mentioned earlier, we have 3 more lectures for you today, covering, first of all, Module 4, Network Security Essentials and Penetration Testing for SMEs. This lecture will be delivered by Wissam. Then Eleni will talk about software security in Module 5. And Dimitris will cover Module 6, Intrusion Detection Systems. Now I will hand it over to Wissam for the first lecture for today. Thank you.
Thank you a lot, Ole. Let me share my screen, first of all. Okay. I hope that you can see my screen. Good morning, everyone, and welcome to this first training session in this webinar. It will be related to network security essentials and penetration testing for SMEs. My name is Wissam Malouli. I'm a senior researcher and CTO in Montimage company, and we are located in Paris, and our expertise is cybersecurity. So for this specific training, the idea is that we'll have some training objectives. At the end of the training, we'll understand more the core network security fundamentals, and we'll learn how to adopt a testing mindset to anticipate attacker path causing operational disruption, and how to recognize and request SME relevant security tools from offensive ecosystems. So the idea is to have practice to build essential defenses to protect your network and also do this proactive testing inside with minimal cost and maximum impact for SMEs. We'll have two big sections. The first one is network security fundamentals, and the second one is how to perform penetration testing in an SME. So for security, network security fundamentals, let's start by the beginning. So it's very important to understand. Seems that there was a problem with sound. I hope it's better now. Okay. So let me continue. So I want to say that today all are using more and more. There is still a connection issue.
Try to switch off your camera, Wissam. So maybe it's a problem of bandwidth.
Yes, let me very quickly disconnect and reconnect if possible. Okay, I will come back. Sorry about this issue. Okay. Okay, I'm back. I hope it's better, and let me share again my screen. Can you hear me better now?
Yeah, now it's better.
Okay, perfect. Sorry about this issue. So let me start from the beginning. So this first training session is about network security essentials and penetration testing for SMEs. My name is Wissam Malouli. I'm a senior researcher and CTO in Montimage. Montimage is located in Paris, and we are expert in cybersecurity. And the objective of the training today is to better understand the core network security fundamentals, how to apply security defenses for your network, and how to adopt a penetration testing mindset to anticipate all the attacker path without causing operational disruption. We would like at the end finally to have this best practices and also understand how to perform this proactive testing with minimal cost and maximum impact for SMEs. In this training, we'll have two. So there is still this internet problem, I guess. We have two main lectures. First one is related to this network security, and the second one is related to penetration testing. So let's go with the first, let's say, part of the training. We need to, and this is something clear, that SMEs are having more and more devices, and they are more and more connected to internet. They use different software and hardware in their company, and of course, these software and hardware may have some vulnerabilities. These software and hardware can be connected. SMEs also rely sometimes on cloud-based services, and they use a lot of Wi-Fi related connections. And of course, since we have that many connected devices and services, these can be potentially some attack channels that can be exploited by attackers to finally get in your network and access to your sensitive information. So indeed, we need to have only one weak part in your network, either a device or software that can be exploited by an attacker, and this will lead to compromising all your network. And that's why it's very important to secure this network, to secure all your devices, to minimize exposure and isolate critical zones, enforce strong credentials, patch regularly, and monitor continuously. So it's something very, very important to do this. What are the weaknesses that we have in SMEs in general? SMEs can use some routers, switches, connected disks that they are called NAS. So it's a networked storage that can run outdated firmware. And when we use outdated firmware, this means that firmware can be vulnerable, and that can be the entry point for attacker. They can also have this remote access control are on the internet. This is, of course, very vulnerable. They can also use some password across devices or use the default password in some devices as IoT, etc. And this is, of course, a big vulnerability because if you don't choose these and rely on, let's say, strong password, this can be a weakness for your whole network. Another problem is SMEs, since they are not very big and they have this, let's say, IT infrastructure, they only have a flat local access network. So everything is connected to everything. They don't have this segmentation in their network, and this is also a problem because this isolation between user devices and critical zones is not done effectively. In the same way, we can have also issues without this, where SMEs do not collect any logs about what is happening in their network, so they don't understand who is connected to what and when, if there is some intrusions, if there is some issues. And of course, if we are not monitoring, we cannot detect, we cannot react. And in this case, we can have also some issues. We can have also problems related to some lack of backups. We can also have some absence of incident response process. That means that we are not foreseeing what kind of issues we can have, and we are not planning how to react to this problem. So when it's happening, we don't know. We are in a stress, let's say, context, and we don't have the plans and the processes that are already predefined to be able to answer these incidents. And these are frequent, let's say, weaknesses in SMEs. That's why there is some good practices, there is some, let's say, cybersecurity principles that need to be applied by SMEs. Here we have some examples. For example, the first one is that we need to assume that we can be attacked, not only from external, but we can also have some internal attacks. That means that we can have people that are already connected in our network. I'm not speaking about only employees. It can be some guests, etc., that are connected to our Wi-Fi, and can be people can be the, let's say, the channels of internal attacks. But we need finally to design defense as if attack may happen at any time. We need also to have this privilege in the sense that we need to restrict who can access to what and when. So only the privilege to access to some assets, to some services, only to the people that need these servers and services to work. We need also to have this zero exposed administration to public internet. So administration is something very, let's say, critical. So it should be done in a very secure environment. So we should not do it remotely, and we should not provide a publicly available IP that allow you to administrate your network. We need to block first and allow only what is justified. So everything should be not authorized at the beginning, and then you give authorization and allow some access to only people that need this access. You need to isolate your business critical environment. So this is related to the segmentation between different zones in your network. So to have this public, for example, Wi-Fi when we have a meeting for your guest that is disconnected from your critical infrastructure network. You need also to monitor, log, to be able to understand what is happening and detect all the issues. And of course, you need to patch fast, test regularly, and prepare recovery and have plans to answer your security incidents when happening. In terms of practical best practices, we need, of course, to perform this security of your network, to have a firewall installed in your network that, first of all, can be used to isolate different zones, but also to define to be able to recognize all malicious activities in your network and stop it automatically. So here we have some examples of firewalls that can be used, but the list is really very big. When you are, let's say, accessing remotely to your servers and services, you can use VPN. This is something that is very important and it's necessary. Of course, if you configure your VPN in the right way, that can be an issue. So you need to have a good configuration for VPN access. And of course, when you use Wi-Fi, you need to create a dedicated guest Wi-Fi that's related from internet sources. Network segmentation is something very important for containment, and of course, to monitor the network and detect and use firewalls, intrusion detection systems, so that you can finally understand who is connected. If there is some new devices that are connected that are not allowed, you can detect them. If there is some unusual login failure, or if there is some open ports that are not used, all this is very important to be put in place. So finally, you need to identify all the issues that you have, classify them, and based on their impact and severity on your network, you need to apply the necessary protection. And you need always to continuously monitor your network, because there will be always threats and issues. So this is the first part of the training. Now we'll see how to perform penetration testing, what we call also pen testing. In fact, let's start with uh, the definition. When we speak about penetration testing, is not only about running tools or simulating attacks, but the idea is to try, and the objective is to try to discover the weaknesses and the vulnerabilities that you have in your network before your adversaries. That means that you will do what we call ethical hacking. You'll try to hack your network and your assets. I say assets, it's your servers, your services, your files, your sensitive information that you'd like to protect. So we'll try to hack them, and of course, by doing that, you will identify your vulnerabilities, you will identify how to exploit these vulnerabilities, and or you can also validate that your defenses are working correctly. And if not, you need to put in place some remediation mechanisms and give some priority on this remediation so that you can effectively secure your assets, and you need to do this work in a very frequent way, because you know that the threat landscape is evolving, and also maybe your network, you are always using new devices or installing new services or new software that can be and then can be used by attackers. And of course, this penetration testing can be also a legal requirement that you need to do, be compliant with some regulation. So in the penetration testing methodology, you will follow several steps. These are the steps that are followed in general also an attacker, where they need to have this reconnaissance phase where they will gather public information that can be related to threats, to information to your system. Then they do some scanning of your system to understand what you have in terms of host, in terms of services, and then they will identify the vulnerabilities related to your assets, and then they will try to exploit these vulnerabilities and maybe do some post-exploitation to maybe try to escalate and access to some to other devices or other files that are sensitive. And of course, you need for your penetration testing to provide a report where we will classify the findings and also provide the action points to have a better secure network. So let's go step by step. As I told you, for the reconnaissance phase, the idea is to rely on open source information to collect, for example, who is domains, what are the subdomains, what are the leaked emails, what are the parameters of IP ranges or cloud assets that are accidentally published by your SME, etc., etc. So a lot of information that you can find on internet, and you can also understand what are finally the threat landscapes, what are the vulnerabilities that you can have, etc., etc. So this reconnaissance is very important. Then the idea is to do this scanning. In general, we'll try to discover all the hosts that you have. You will also, for each host, do this port scanning to understand what are the open ports and what are, and depending on the number of port, you can also understand what kind of services you are running on your host. And you need to enumerate these services and try to detect the vulnerabilities related to these services. You would like also to understand what kind of protocols are used. And for that, there is some tools that you can use for example, like Nmap or Masscan that can do this scanning. Then, when you identify all these services and all the hardware that you are using, the idea is to map them to known vulnerabilities. These known vulnerabilities are in general publicly available in different databases, like the MITRE CVU database or the national vulnerability database. There is also a new European vulnerability database that you can find on internet. If I write, for example, European vulnerability database, you can find it here, and here you have the list of vulnerabilities that you can search. This is something new, and it's supported by ENISA, as you can see here. But you can also use other known databases, like the one that is provided by MITRE. So here, for example, if you are using, let's say, a Tomcat server for your web application, here you will see that you have 407 vulnerabilities that can be exploited by attackers, and some of them are discovered, as you can see here, in 2025. So they are somehow recent. So this is something very important to be done. And based on that, you will try to exploit these vulnerabilities to apply some attacks different kind of attacks. Here we have some list of attacks with brute force or exploitation and patches SMB or, and all this will try to exploit these vulnerabilities. The post-exploitation is to try to validate whether an attacker could escalate privileges to have, for example, more laterally between devices or reach backups or share the storage with sensitive files, maintain persistence or deploy ransomware internally, etc. These findings will allow you to define what are the remediation priority that you'd like to apply. And all these need to be somehow reported in a document where we say what kind of tools and methodology you did for your penetration testing, what you identified as vulnerabilities and exploit. Of course, you need to rank them based on their severity and likelihood, and of course provide recommendation for fixes, etc. So this is something very important. There is a lot of tools, tons of tools to do penetration testing. Here I have some examples, but the list is really very, very big to do this network scanning, to do this web application vulnerability scanning, to do some testing, etc. So maybe you know some of them, like we already spoke about Nmap, but maybe you know Wireshark, OWASP, ZAP, for example, Metasploit, etc. There is also a lot of tools that are powered by AI, like Deep Exploit, Chenina. We have in our company Network Fuzzer that use also some AI-based penetration testing. It's a Network Fuzzer. All these tools can be either this is something very important for SME can be free or open source. So this is good for SMEs. Of course, you can also find paid solutions. And my recommendation is to use some penetration testing environments. Here I give only two of them, but the list is bigger than that. For example, Kali Linux or Parrot OS operating system. They are already operating system that contains tons of penetration testing tools that you can use to do this kind of discovery of vulnerability, exploit, etc. And these tools are already pre-installed in this operating system. And when you install Kali Linux or Parrot OS, you have already access to these tools, as you can see here. Let me go very, very quickly, for example, to Kali Linux. So you can, of course, download it from the official website. And if you go, for example, to the list of Kali Linux tools, you can see here tons of tools that can be used and how to run them to do your penetration testing. So you see the list is really huge and big. Of course, today we'll not have time to see all these tools, but of course, it's very important to know that to do penetration testing, you need to apply different solutions, different tests, etc. Here I have a small video, maybe you can see it, where we are now trying to use OpenVAS. OpenVAS is Open Vulnerability Assessment System, where we can launch a new scan. So here we call scan 2. We need to identify our target, scan target. It can be one system, or you can create a new target, of course, providing the IP address or the range of IPs that you'd like to scan. And of course, you can schedule many scans, for example, and or do it once. So there is some configuration for your scan, but you can also use the default one that are available here. And as I told you, we are using OpenVAS. We are in the context of Kali Linux, so we are. It's one of the tools that you can use in Kali Linux, and of course the idea is to be able to launch automatically some scans to identify some vulnerabilities related to your system. So here we choose some scan configuration fast, full and fast. And here, as you can see, we created a new scan. We didn't run it yet. And of course, by clicking here, we can start the scanning. Of course, the scanning can take time. In general, it's a matter of minutes, hours, depending on the target system. But after a specific time, you will find some results. That's why here we'll stop a bit and come again and to see the result of the scanning. So when is done, it will be notified. And of course, by clicking on the scan result, you will see the details of what has been found as issues. And we see here, for example, we identified 6 vulnerabilities that are with high severity, 13 with medium, 3 with low, etc. And we can go deeply by clicking on them. And if I click on the list of let's say vulnerabilities, we can see the result, and we can see here, for example, in the result part. Let me go to the result. Here we have the duration, how many hosts, etc. But in the result, you can see the details of the vulnerabilities that has been detected, etc. You can link them to some SMEs that are vulnerabilities that are the rest of these vulnerabilities, and vulnerability, you will what kind of mitigation action you need to apply. I will not continue the video because I think I'm already out of time. Let me go directly to the details of this training. So first of all, the security for SMEs is a business enabler, not a lecture. Testing your network is part of your resilience. You need to identify the vulnerable asset and apply mitigation action, and this is a must. And of course, you need to protect your business by doing this penetration testing, doing this smart penetration testing, patch fast and isolate by design your solution. And this is the end of the training. Sorry for the quality of the network today. I hope that it was clear for everyone. And let's go to the questions if there is any question.
Yes, thank you, Wissam. Yes, now please, to everyone, if you have a question, please post them in the Q&A box. Maybe let's wait for 1 or 2 minutes for everyone to type
Yeah,
their
sure.
question.
I don't see any specific question. Maybe I hope that it was clear. And of course, as stated from the beginning, all the recording will be available on the NERO website after this training session. Thank you. Thank you all.
Yes, thanks again, Wissam. Of course, if you have a question or if a question pops up later, you can always ask them in the Q&A box, and then Wissam can answer in the chat, or we can do a quick Q&A at the end again. Yes, now then I would hand it over to Eleni for the next lecture.
Thank you, Ule. Thank you very much. So I will share my screen. So I guess you can see my presentation right now. So let me welcome everyone to this module, Module 5. As you can see, we are going to focus on how SMEs can leverage tools like Snyk to achieve advanced software security My name is Eleni Seralidou. I am a project manager in Trastilio. Allow me a few seconds to say a few just short information about Trastilio. We offer hands-on training and consulting services. So our mission is to help teams adopt best practices, integrate new tools and policies, and cultivate lifelong learning in trust and security. So you can contact us through our website. You see the details in the slide. So here's today's agenda. We will start by understanding why SMEs need more than basic scanning tools. Then we can dive into advanced detection using this time the Snyk tool. We can review prioritization, container security, infrastructure as a code, privacy risks, and finally we can see some demos as we walk through with some practical examples. All this information about this course, you can find it also in our Moodle training platform. You can see the links here in this slide. The first link, the LMS NERO Cybersecurity, is our training platform, which includes information about this course. And of course, our website with the entire collection of the tools that we provide for SMEs. In previous trainings that we had for the specific module, we covered some cybersecurity, some software, security basics and fundamentals of using Snyk. And now we will add up to this information, previous information that we shared. So as a recap, a quick recap for our previous training is that we covered security fundamentals, as I said, common OWASP vulnerabilities, and basics of Snyk scanning. So building on that, and we will see how Snyk enables more advanced, probably real-world security workflows. So the goal is by the end of this module to be able to understand how this tool, Snyk, and similar tools as Snyk, because Snyk is not the only one that performs these actions, how it can detect real threats, how it can prioritize these threats and prioritize them by using an algorithm and what matters most, and how infrastructure as a code scanning protects privacy, about our container images, how can we scan and lead to fast remediation of the vulnerabilities that we see. So just a few information about what actually is Snyk. So Snyk is a developer security platform that scans the code that we have, scans dependencies, scans containers, and infrastructure as a code. So the key value is that it integrates directly into the developer workflows. So you are able to catch any issue early, not weeks later at the security review stage. So adding up on that, why SMEs need more than this basic scanning that we mentioned? SMEs often have limited security staff, probably, and they rely heavily on open source and cloud technologies. So this increases the chance of misconfigurations or vulnerabilities slipping in, and attackers actively exploit publicly known vulnerabilities. So SMEs need tools that can prioritize and guide them, not just produce this long list of CVEs. So this type of tools like Snyk help SMEs focus to what really matters. So as I told you, this tool performs a prioritization. So it has a way to produce a priority score, a prioritization score that goes beyond the CVSS. So it considers exploit maturity, the impact on your application, and how the dependency is used. And this help to focus on issues that attackers can truly reach. In order to produce this score and have this prioritization, it has some code factors that it uses, and it has its own algorithm and produces a final score taking under consideration these code factors, as you see, exploit maturity, reachability, fixability, etc. And based on this algorithm that it has, it produces a prioritization score so we can see which vulnerabilities are higher and which are lower in the score. So now let's see some actual categories of examples. Let's start with exploit, maturity, and dependencies. So about exploit maturity, this determines how easy a vulnerability is to exploit in the real world. So combined with dependency analysis, Snyk highlights issues that are actually reachable and dangerous, not just technically present. So attackers can exploit these vulnerabilities that have known public exploits. So I will try now to bring forth the window of Snyk, the tool, the actual tool. I will make it like full screen here. Okay, and I will demonstrate an example. I have connected a project. Probably if you haven't used a similar tool like Snyk, you need to walk through how we can connect a project by using a GitHub repository, etc. It provides several options and we can connect it and pull it and perform scans in it. I have pulled two projects as examples. So let's go to the first one and demonstrate what we are discussing now. Hopefully it will open and I will not have an issue. Okay, so we see now an example of this project. Let me just go to the first file here. Probably will take some time to load. Okay, so here you can see it opened this set of vulnerabilities that it found. You can see on the left that it has a lot of filters that we can use, and as we scroll down we reach to this part of exploit maturity. So as you can see, we have a lot of categories in which we can select about the maturity that we have. So here we can see some examples of critical. You see, I don't have the mature option here, but in other examples you may see it. I have the proof of concept, so I can select this, and you can see it isolated some of the examples. So I can go here and open the information so I can see what this proof of concept means. It means that I have a detailed explanation of how to exploit this vulnerability, and it also provides other information about where it was introduced. Also, it opens some known libraries in order to provide more information about this vulnerability that it found, and you can learn also, you can reach more information and learn about this type of vulnerability. So here you can see a lot of things about this critical vulnerability that it was scanned, and also, as you can see here, it has the variable dependencies. So if I click here, it shows me which of the dependencies have critical issues. So I can walk through this again, and I can see how I will move on in order to fix my code and rescan and overcome all this set of vulnerability. So this is a very good thing that we can use in order to see the prioritization. It's prioritized as critical, as high, as low, as medium, and also see about the categories that we have, if it's mature, if we have a non-known exploit, and etc., and other filters as well. So for this part, why do we need something like that? We can see that whether an attacker can exploit this depends on whether the vulnerable library is actually used. So that's why exploit maturity and dependency paths are essential for prioritization. So we have this type of information displayed here. So this is a first example I'm moving on to the next. So about container security for SMEs. Now, most SMEs deploy applications using containers. Container images, especially base images, often contain hundreds of vulnerabilities. So SMEs may not update base images frequently. So actually hardening your base image can drastically reduce risk with minimal effort, because a huge portion of risk comes from the base image, actually, probably not the code that we have. So Snyk, this tool, can tell you which base image to upgrade to, whether unnecessary packages are present, and what configuration issues exist. So often a single base image update removes the majority of the vulnerabilities. So let's see a second example about that. If it doesn't work for me, I also included some slides to walk you through, but probably it will work. So let's see a second example about a container that we have, probably this one. So you see in this window that we can retest the project that we have connected. I tried to retest it 2 hours ago to see if everything works fine. Probably I can retest it now. Hopefully it will work because I did it 2 hours ago. So this retests my project to scan again for vulnerabilities that were found. So you can see here that it showed me some recommendations for upgrading the base image. Beside that, you can see that I have again a long list of vulnerabilities that were scanned in this project that I have connected. And again, I have all the filters that can isolate. For example, here I have also mature that has a published code exploit for this vulnerability, etc. So it also suggests a fix for me. You can see that I have the current image, some minor upgrades and some major upgrades. So I can open a fix pull request. I will do it now. Probably will take a few seconds, okay? So it gives me the information that I have the current base image with a PHP 7.0, and now I can upgrade this image to a next version of PHP. So I can open a fix pull request, and it will provide the information that I need for this upgrade that I'm about to perform. So it gives me all the information, the issues that I have, everything. I need to walk through all this. And it also provides information about the changes that are going to happen. So which files are going to be changed. I can see the changes that are going to happen here. So I can move on with the merge of this pull request, of this fix pull request. And then if I perform the merge, it's going to take some time. So I will skip it. You can try it though. And if I perform this merge and update my code, then I can retest, and then you will see that the number of vulnerabilities is going to decrease. It's going to be lower, not so high. So this is a second thing that we can focus. As I told you, I included a couple of slides here in case of I had any issues, are the same slides as the example, and they're going to be available as well to the Moodle platform for this training module. And now I will move on to the next. So privacy risks from infrastructure as a code misconfigurations. So let's see a few things about that. Infrastructure as code gives teams like speed, consistency, but it also means that if we have a single misconfiguration, probably sensitive data can be exposed. So SMEs often lack this deep cloud security knowledge. So errors like overly permissive access or unintended exposure can slip in unnoticed. So infrastructure as a code is very critical for privacy protection. So let's see also some actual infrastructure as a code issues that can be detected through Snyk. I will bring again forth this window of Snyk. And what I need to show you right now is the code analysis. So I will go right here in the code analysis. So let's see, we have a lot of vulnerabilities here as well. I will take, let me just take firstly the information exposure, because I need to show you, I'm saying that we can fix the vulnerabilities, etc. But there are also cases that I might have a vulnerability. This is, of course, medium vulnerability. But if I go and view the details, it shows me where the problem is. You can see here, the problematic code is highlighted with yellow, and it shows, of course, the data flow information. And you can see here that I am in the tag data flow. And if I go to the fix analysis, I should have seen here an example of fix. So why am I showing this? Because all the vulnerabilities that does not have example of fixes, some of them are empty, but they give best practices for prevention. So you can walk through the details that they provide in order to find a way to improve your code. But this is not for all the types of vulnerabilities. For example, if we go, let me just say the server one. Okay, the request forgery. So if I go here and view the details, you can see I have again all the information. I can go to libraries and see and learn about this type of vulnerability, a lot of information. If I go to the details, you can see again here my problematic code is highlighted. So I can go to fix analysis, and here I can see examples of actual fixes. What it is suggested to me, what I can change in my code. The green one is what is suggested, and it would be safer for me to use. So I have actually 3 examples here. I have the second one that it is suggested to me, and I have a third one also that it is suggested to me, and I can use it and change my code, fix my code, and rescan and see if this vulnerability has been overcome and I don't have it anymore in my code. So as I told you before, I also included some slides in case of problems if I had issues. This is exactly the example I show you. So I'm moving forth. I included another slide about how this tool can also inform policies automatically. So this means you can use it and block risky merges, or maybe enforce some license rules or trigger alerts without adding more workload to your security team. You can just adjust it, and this will go on automatically. So as a conclusion, exploit maturity helps you focus on real threats. Container hardening provides fast wins. Infrastructure as a code scanning prevents privacy leaks before they happen. And this automation helps SMEs stay secure without slowing development. So we went a step further beyond just scanning your code, and we saw how we can support threat detection and privacy protection. And I always like to conclude with this slide that all our code is guilty until proven innocent. So we need to scan our code for vulnerabilities and improve our code all the time in order to be more secure. So thank you very much. I
Yes,
concluded.
thank you,
Thank
Eleni.
you.
Thank you so
Yes.
much. Now we have time for more questions. So if you have any question to Eleni, please post them in the chat. Sorry, in the Q&A box. I think again, we wait for 1 or 2 minutes. If anybody is typing. Yes, we have a question from anonymous or from an anonymous attendee. You want to read it yourself, Eleni, or should I read
Yes,
it?
whatever you like, I can read it. If you
Yes.
like. Yeah. It says, so considering our limited resources, how can we design our software systems to proactively detect security threats and safeguard sensitive data while minimizing operational overhead? Additionally, are tools like Snyk practical and cost-effective for SMEs to implement for continuous security monitoring? So let me start from the second part. I think it is practical. I need to clarify. Snyk is not the only tool that performs these actions. We have other tools as well, C2M, etc. Some of them are cost-free. Some of them we need to pay, and some of them are expensive. Honestly expensive. So you need to find, each SME needs to find the right solution that they need. They need to see exactly what is their problem and where they need to focus in order to take the right tool. So it is practical to scan your code, and it is effective because there are a lot of cost solution as well that you can select. There are solutions that are cheaper. There are solutions that are most expensive. You will see it depending on what you can cover. This is one. And the second one that you say, considering our limited resources, how can we design our software systems to detect security threats? So this is something that you need to consider when you try to design a system. This needs a lot of discussion to cover it. The phase that we have for designing a system, when we are trying to figure out how we are going to proceed and how we are going to design it and have our code, etc., is a very important phase. So there you need to see how you are going to, focus and work with that. So if you have, I don't know if we have enough time to discuss about it, but if you want, we can discuss about this further. Drop me an email and we can have a larger discussion about that. Thank you.
Okay, thank you, Eleni. Any more questions? Please write them in the chat. I don't see any right now, so I think we can continue. But if you have more questions, just write them in the chat. Thank you, Eleni, again. And now, yes, I will hand over to Dimitris for the third lecture of today.
Okay, thank you, Ole. Let me share my screen. Can you see my screen?
Yes.
Hopefully, yes. Perfect. So, hello everyone from me. I'm Dimitris Asimopoulos. I'm coming from MetaMind Innovations. That's a spin-off of the University of Western Macedonia. And we are focusing on developing AI and IoT solutions for different critical infrastructures. And we also focus on smart grid and meter development and data analytics. So this webinar is focusing and is guiding you through the fundamentals and advanced concepts in network intrusion detection systems, or NIDS. This focuses on strengthening cybersecurity awareness and resilience, especially in SMEs, that are now increasingly targeted because there are lack of resources for complex security infrastructures. And this makes intelligent and effective intrusion detection absolutely critical. So just a moment. Perfect. The agenda for today is we're going to start with a small introduction in the network intrusion detection systems. We're going to talk about some common attacks, deployment strategy, how we select appropriate needs products, different models and message exchanges, understanding the output of the network intrusion detections. And we are going to conclude with some advanced concepts in network intrusion detection system where we are using machine learning and AI-based analytics. So let's start with the fundamental concept of network intrusion detection systems. At this core, intrusion detection means continuously monitoring network activity and analyzing it if for suspicious or malicious behavior. These behaviors, called intrusions, can include attempts to compromise confidentiality, integrity, or availability, as well as efforts for bypass existing security controls. Important intrusions don't only come from outside the organizations, but they can be or can originate from insiders, either maliciously or unintentionally. This is where network intrusion detection systems come into play. NIDS are hardware or software solutions that automate the monitoring and analysis of network traffic, helping security teams to detect different threats that might otherwise go unnoticed. So why should organizations use NIDS? That's a very important question. This is because modern environments are highly interconnected and increasingly complex. As attack surfaces grow, manual monitoring becomes unrealistic. NIDS provides visibility, early warning, and context, allowing organizations to respond to these threats effectively. To understand this better, let's look how NIDS work. NIDS operates by capturing and analyzing network packets as they move across the network. By monitoring a specific segment, such as switch or critical subnet, a NIDS can observe traffic that affects multiple hosts simultaneously, providing a broader security view. Typically, NIDS are composed of sensors placed on strategic points in the network. These sensors analyze, as mentioned before, traffic locally and then report potential attack or anomalies to a center management console. One of the main advantages of this approach is scalability. A relatively small number of well-placed sensors can effectively monitor a large network. Another key benefit is that NIDS are usually passive systems. They listen to traffic instead of interfering with it, which means they have minimal impact on network performance and are easier to integrate into existing infrastructures. And finally, because NIDS do not sit in line, they can often operate stealthily, making them harder for attackers to detect or evade. Despite the strengths, NIDS also has some disadvantages. The first is that it's large and heavily loaded networks. A NIDS may struggle to process the packets in real time, especially during peak traffic periods. This can lead to miss some attacks. There are also visibility constraints. Most network switches rely on port mirroring, and a single monitoring port may not capture all the traffic correctly, limiting what the NIDS can actually see. Another key limitation is that NIDS detect the initiation of an attack, but do not necessarily are successful. This means alerts often require manual validation, increasing the workload for the security teams of the companies. Understanding this trade-off is important, since NIDS are more effective when deployed as a part of a layered security strategy than relied upon in isolation. Before discussing how NIDS detect threats, it's useful to look at what type of attacks they are commonly designed to identify. One of them is denial of service attacks, where attackers overwhelm a system with extensive requests, causing services to slow down or become unavailable. NIDS can also detect port scanning activity, where the attackers scan a range of ports to identify open or vulnerable services that could exploit the further attacks. At the application level, attacks such as SQL injection and cross-site scripting involve injecting malicious code into web applications to access data or execute unauthorized actions. Another important category is man-in-the-middle attacks, one of the most common attacks, where all the attackers intercept or alert communication between two parties. And finally, we've got the ARP spoofing, where it targets local networks by redirecting traffic through the attacker's device. These examples are some of the attacks that are NIDS detect, and it brings us to the next topic, which is how NIDS actually detect malicious activity. The first major category is anomaly-based detection, where this approach involves learning what normal behavior looks like over time and the flagging deviations from the baseline. Within anomaly detection, we often distinguish threshold-based detection, where predefined limits trigger alerts, and profile-based detection, where the system builds activity, profiles per user or entity, and monitors abnormal behavior. The second category is rule-based or signature-based detection. Here, predefined rules or known attack patterns are used to detect intrusions. This works very well for known threats, but struggles with new or evolving attacks. And finally, we have the heuristic and hybrid detection, which combines multiple techniques, patterns, anomaly detection, and heuristic rules to improve detection coverage and reduce blind spots. In rule-based detection, it's important to see how we are going to use different techniques to detect needs. The first example is if a single source IP scans more than 20 different ports within 10 seconds, generate an alert. This is a classic indicator of reconnaissance activity. Another rule-based example is repeated authentication failures, more than 5 failed login attempts with 30 seconds. This is another rule-based that often signals that's a brute force attack. In contrast, the second is the anomaly-based detection, might flag a sudden abnormal spike in SYN packets within a short time window. While this behavior is not so clear, it's more common to be a denial of service attack. These examples clearly show how different detection methods complement each other. When deploying a NIDS, the key architectural decision is the sensor placement of the NIDS. NIDS rely on strategical positioned sensors that monitor traffic flowing through specific network points. These sensors can often should be deployed in multiple locations to maximize visibility. As shown here, sensors can be placed at the network perimeter within the internal network or near critical assets. Each placement provides a different perspective on traffic and detects different types of threats. The goal over here is not to coverage everywhere, but intelligent placement based on risk, network topology, and asset criticality. Let's dip a little bit more in each location individual. So, in the first location, a very common deployment is placing a NIDS behind the external firewall in the demilitarized zone. From this position, the NIDS can monitor attacks that have successfully passed the perimeter defenses. This is particularly useful for identifying firewall misconfigurations or overlay permissions rules. It also helps protect critical DMZ assets, such as web servers and database. Placing the NIDS outside the external firewall in location 2 allows organizations to observe raw internet traffic and document incoming attack patterns. The third location is deploying a NIDS on the network backbone gives visibility into large volume of internet traffic. This increases the likelihood of detecting lateral movement or misuse by unauthorized users. And finally, we've got location 4, where deploying NIDS in critical subnets focuses detection on high-value assets, such as database, control system, or sensitive applications, where early detection is most impactful. Next, we will discuss how to choose the right NID solution and interpret its output effectively. So, at the edge, we have the sensors, which continuously monitor network traffic and generate events. These events generated are set to an analyzer where traffic is examined against detection logic to identify potential threats. If suspicious activity is detected, an alert is generated and forwarded to the manager, which acts as the system's coordination point. The manager handles alert aggregation, notifications, logging, and reporting. Based on these alerts, the operator is notified and can initiate a response or escalation based on the alert. Meanwhile, the administrator defines security policies and configurations that guide how sensors and analyzers behave. When selecting a NIDS, the first step is understanding the technical and policy context of the network. This includes identifying a system environment, network size architecture, and performance constraints. It's also important to define security objectives that are focused primarily on external threats, internal missions, or both. It's also important to organizations to evaluate how policy violations are currently handled and whether detection workflows align with operational realities. A NIDS is important to support, not complicate the organization's security strategy. Next, we consider the appropriate requirements and constraints for the NIDS. This includes regularity on legislative obligations, for example, protecting medical or personal data. Budget is another key factor, not just for acquisition, but for long-term maintenance and staffing. And equally important is having a response plan where detection without a response strategy provides limited value. A NIDS is most effective when it integrates into an established incident response process. Finally, the NIDS product itself must be evaluated. Scalability is critical. It can help grow with the system or with the organization. Testing the product in the real environment is also highly recommended. The other quality feature is a tool erase of use matters. A tool that requires excessive expertise may increase operational risk. Vendor support is also a key factor where update frequency, technical support, and long-term commitment all influences system effectiveness. And finally, we have training availability and cost should be considered, where a well-supported and well-understood NIDS always outperform a more complex system that remains under safety. Detecting an attack is only useful if we can correctly interpret the output generated by the NIDS. As mentioned in the beginning, that's very important. Typically, NIDS alerts include standard fields such as the time and date of the event, source and destination of the IP address, port numbers, and the network protocol used. They also specify the type of attack or suspicious behavior detected. In more advanced setups, alerts may include additional information like attack severity, a textual description, references to known vulnerabilities, or even custom organization fields. Understanding this output is critical. Missing some alerts can lead to false alarms or worse, missed incidents. There are several common misconceptions regarding NIDS and firewalls. especially in smaller organizations. First, NIDS and firewalls do not perform the same both. Firewalls control traffic based on predefined rules. NIDS, on the other hand, monitors and analyzes traffic to identify suspicious behavior. Second, a firewall alone is not sufficient for security. It filters traffic, but it cannot detect advanced threats like zero-day attacks in these days or lateral movement. NIDS provides visibility into this type of activities, in the other hand. And finally, NIDS do not prevent attacks directly. They perform detection, not prevention. For active blocking, organizations need intrusion prevention system to be safe. Another common belief is that firewalls can detect intrusions. In reality, firewalls mainly inspect IP addresses, ports, or protocols. They do not analyze traffic content, but NIDS, in contrast, can detect malware partners, abnormal behavior, and known attack signatures. Finally, neither NIDS nor firewalls alone can make a network fully secure. Security requires a layered approach combining network monitoring, endpoint protection, encryption, access control, and user awareness. Understanding these roles correctly helps organizations deploy the security tools strategically rather than redundantly. So, there are several widely used open source NIDS tools, such as Snort, Suricata, Snyk, and more. Suricata, I'm going to talk a bit more since it is more known, is a high-performance alternative that supports multi-threading, deep packet inspection, file extraction, and TLS decryption, while remaining compatible with the Snort rules above. Traditionally, NIDS are mainly based on predefined rules and known attack signatures. While this is effective for the previous years, this has some limitations since there are nowadays new or evolving threats coming in front, such as zero-day attacks. This is where machine learning and AI comes in. Instead of relying only on known patterns, AI-based network intrusion detections can learn what normal network behavior looks like and detect anomalies that may indicate an attack. Another important benefit is adaptability. As networks and attack techniques evolve, machine learning-based systems can be retrained and adjust over time. Finally, AI can help reduce false positives by distinguishing between benign anomalies and real security threats, which is especially important for operational teams. Perfect. Here is how we're going to train an AI machine-based network intrusion detection system. First step is to detect and collect network traffic data. Create network traffic dataset that contain both normal and malicious network traffic. Use tools like Wireshark, TCP dump, or a simulated environment to capture raw network packets. In the second step, we are going to need to extract network flow-based features, load the pickup files, and extract the features. And finally, in the third step, we're going to have the data pre-processing, where we need to ensure that each network flow is labeled as either benign or an attack type, such as SQL, denial of service, port scanning, etc. Remove or impute missing or incorrect data, normalize numerical features, reduce dimensionality using techniques like PCA, and if categorical feature exists, encode them. Step 4 is once the machine learning model is trained, it is integrated into real time network intrusion detection environment, where it's analyzing live traffic. Importantly, after that we have the evaluate performance. On the testing set, we evaluate metrics such as accuracy, F1 score, true positive rate, false positive rate. And over here, it's important to say that AI-based NIDS are not static systems. They must be updated and retrained periodically to remain effective as network behavior and attack techniques evolve. In practice, AI enhances traditional NIDS rather than replacing them, forming part of a hybrid detection strategy that balances accuracy, adaptability, and operational simplicity. I think that's enough for today, so thank you very much. If there is any question.
Yes, thank you, Dimitris. Exactly. So if you have any question, please post them in the Q&A box. Let's wait for a few minutes and see if anybody posts any questions. If you happen to have any questions for any of the other panelists, you can already write them as well. We can answer them afterwards too. All right. Yes. Thank you, Dimitri, again.
Thank you very much.
I would suggest we move on. Share my slides again. So yes, now we have covered all the modules for today. The last point on the agenda will be the post-training questionnaire. We would be very happy if you could fill this questionnaire as well. It's again part of our research efforts within the project. Yes, so I will give a couple of minutes to fill this questionnaire. And again, if you would like to have the certificate of attendance for this session, we ask you to fill the questionnaire, and at the end you will give your email address, and then we will send you the certificate. And you can also find the link in the chat. All right. So while you go through the questionnaire, let me cover maybe the remaining few points of today. So this was the second part, as I mentioned in the beginning of our webinar training series. But there's a third part, immersive and gamified cybersecurity practices for SMEs, which will cover again 3 lectures, which will include some more hands-on parts as well. And this will take place on 19th of January next year. I mean, it's not that far away anymore. Yes, same time, 10 to 11:30 CET. And if you want more information on all our events, you can visit nerocybersecurity.eu/events. There you will find the sign up for the next webinars, but also any other events of the NERO project. Yes, one thing to mention, the recordings and the slides will also be linked through that web page, through the pages of the specific events. So if you go to nerocybersecurity.eu/events, and you click on, for example, today's webinar, we will link the recordings and the slides that are uploaded. We will link it through that page as well. And of course, also for the first webinar. Those are already uploaded. Yes, then a few more hints where you can see more about the NERO project. You can follow us on LinkedIn, YouTube, X, or any of the other, as of course also on the NERO cybersecurity website. Yes, that was it for today. Thank you so much for joining. And yes, happy holidays in a few weeks. I will bring again the QR code now before we stop the session if you want to scan it quickly, or just follow the link in the chat. Thank you.